Tonight we begin our statistics class with section 1.1, and we are going to be focusing here at the beginning of the course on some definitions. First of all, definitions of statistics, and then probability, and then other key terms that we want to take a look at. First of all, statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. Organizing and summarizing this data is called descriptive statistics. So after we've gathered the data, if we start organizing it and summarizing it and drawing conclusions from it, not really drawing conclusions, sorry, just organizing and summarizing, that is called a descriptive statistic. The formal methods for drawing conclusions from data are called inferential statistics. So that's where we're actually using that information that we've already organized, we've already summarized, but now we're going to draw in conclusions from that or make inferences from those statistics, and that is inferential statistics. For our first example, it says a popular program boasted remarkable reading achievement called Your Baby Can Read, which promises that with the use of flashcards, DVDs, pop-up books, and some quality time between parent and child, almost any preschooler could learn to read before they even entered kindergarten. Does this mean that all parents should buy and use this program? Well, hopefully you're thinking about this critically, and just because a company or a program makes a claim like this does not mean that, it is guaranteed to be true. In fact, most of the time, you're going to want some statistics. I mean, that's what advertising is all about, getting people to believe what you say, and hopefully you're backing that those comments up and those claims up with data, but a lot of times advertising is just, let's appeal to people and hope that they buy our stuff. So in this case, yeah, they say that. They make those promises that the use of flashcards, DVDs, and books and some quality time, so they're making those promises, but they are not giving us any statistics to back that up. So no, that doesn't mean that all parents should run out and buy this program. Now, it doesn't mean that it doesn't work. No, it might work, but they aren't giving us any information at this point to make that claim. Probability is the mathematical tool used to study randomness. This deals with the chance or the likelihood that an event will occur. Okay, so probability is the study of figuring out what are the chances that something will occur. And one thing that we use a lot in society is we might use flipping a coin, because there's a 50-50 chance that heads will occur or that tails. It's supposed to be an even chance for both of those things occurring, and that's the likelihood or the chances that something happens. So for this example, there are a couple ways that we use probabilities as predictions. First, to predict the likelihood of an earthquake, of rain, or whether you will get an A in this course, we could use probabilities. And specifically, recently with weather and stuff, a lot of times you'll hear, oh, there's 35% chance of rain or 50% chance of snow or whatever, and those are probabilities that are used as predictions. The second one, doctors use probability to determine the chance of a vaccination causing the disease that the vaccination is supposed to prevent. A few years ago with COVID, and COVID is still kind of hanging around, but they were giving vaccines. And so the question was, is the vaccine actually causing people to get this disease, or is it preventing it? So the doctors will use that probability prediction to say, oh, yeah, this vaccine is safe, or this vaccine is unsafe. All right, now some key terms. The first one is a population. A population is a collection, a group of persons, things, or objects that are under study. So it's a collection or a group of persons, people, things, or objects under study. Next, a sample. A sample is a subset or a smaller group within the original group, a subset of the population, and we study the sample to gain information about the population. The idea here is we usually can't study everything in the entire population, depending on how large that population is. So we find a sample, a smaller group within that population, and we study that instead. A parameter is a number that gives us a property about the population. Okay, so it's a number that gives us a property about the population. And then similarly, a statistic is a number that represents or gives us a property about the sample. Okay, so we could have a couple of situations. Let's say our population is the entire state of Missouri. Okay, and then a parameter would be, and I'm just making this up, but 50% of the population in the state of Missouri is over 40 years old. So that would be a parameter. On the other hand, if I took a sample, and let's say that our sample is Berry County, and this is a sample out of the population, it's a smaller group within the larger group, and then we said the exact same information. Well, actually, let's change it a little bit just so it's different. Let's say that 40% of the population of Berry County is over 40 years old. That would be a statistic. So the population and the parameter go together. The parameter gives us information about the population, and then the statistic is going to go with the sample. So they're giving us similar information, but parameters give us information about the population, and statistics give us information about the sample. And then another term we have here is a variable. This is notated by capital letters. We might use X or whatever. And this is a characteristic of interest for each subject in the population. And when we talk about the subjects, we're back into that collection of persons. So it might be a person, or it could be a thing, or it could be an object. So it just means whatever we're studying at the time, the subject is just one of those things in the population. So in the examples that I gave about the percentage of people over 40 years old, that would be our variable. Our variable is the age of the people for the example that I gave. So that would be an example of a variable. And if you're using age, you might use a capital A instead of a capital X. Who knows? A lot of times we use X though. Example 1.3, determine whether the given is a parameter or a statistic, and then list the respective sample or population. Some of these can be a little bit tricky because a lot of times you can find a bigger population when you're dealing even with populations, but let's take a look at this. And then it says identify the variable denoted by X. So that's our variable. Part A, suppose that the percentage of all students on your campus that have a job is 84.9%. Well, here is a key word right here, all. All, if you're talking about all of the students, that means you are dealing with a population. Okay? And that means since we are dealing with a population, this 84.9% is a parameter, because populations, that's not how you spell parameter, parameter. Parameters give us information about a population. And then what is the variable? The variable is they have a job. So X is people who have a job. I should say students who have a job. Students on our campus that have a job. Okay. Part B, suppose that a sample of 250 students is obtained, and from this sample we find that 86.4% have a job. Well, again, this time they kind of gave it away for us. This time we are definitely talking about a sample, and if this is a sample, that means the 86.4% is a statistic. because statistics give us information about samples. And then the variable, again, is the same thing, and I want to clarify this a little bit. So this is students on campus. Is that what it says? Yep, students from our campus who have a job. So that is what the 84.9 is telling us. That's also what the 86.4 is telling us. But one of them is giving us information about the entire population, and the other one is giving us information about a sample. So the population example there, part A, is a parameter, and the one for part B, dealing with a sample, is a statistic. Variables that allow for classification based on attributes or characteristics are called qualitative or categorical variables. Qualitative, that word is very similar to qualities. Categories, that's kind of self-explanatory. You've got groups, you've got categories, and these are variables that are classified based on their attributes or their characteristics. Might be numbers, but a lot of times these are something else. It might be colors, might be types of something, styles of something, but they have qualities and categories for these. So qualitative or categorical variables. Variables that have numerical measurements of individuals are called numerical or quantitative variables. So you see that word numerical. And then quantitative, that's like the word quantity, which is also dealing with numbers. And so when you're talking about measurements, a lot of times you're dealing with those numerical or quantitative variables. Arithmetic operations are performed on these values of a numerical variable, and they produce significant results. So for example, a telephone number is not really a numerical or a quantitative variable. That would probably be more categorical, or like maybe an area code. Let's do it that way. Because if you add two area codes together, does it really give you any information? Same thing with zip codes. Zip codes, they tell you individual cities or parts of a city. You can't subtract them or average them and have it really give you any important information or any usable information. Hopefully I didn't give too many of these away, but let's take a look at example 1.4. A researcher studied factors that affect eating habits of adults in their mid-30s. Classify each of the following variables considered in the study as a categorical or a numerical piece of information. So nationality. Well, pretty clearly that is not numerical. That is going to be categorical. Second, number of children. Okay, well that one, number of children, that is going to be numerical. Okay, level of education. This one might be a little bit different, but let's assume that we're talking about like high school, where you're talking about like elementary and high school, where you might be talking about 3rd grade or 9th grade or 12th grade. And in that case, we would be dealing with numerical. Numerical. That's supposed to say numerical. And the reason we want to think about that is, okay, so if you take the difference between 9th grade and 6th grade and you get 3, well, what does that mean? It means that the person who is in 9th grade is 3 grades higher or above the person who's in 6th grade. Now, if you're talking about degrees in upper education, like a bachelor's degree or an associate's degree or a master's degree or a doctorate, then that would switch and that would become categorical because there's no numbers involved. You can't subtract them. That wouldn't really make any sense. But you're dealing with a different thing there if you're talking about, in fact, let me even make a note of that, elementary and high school, and then it would be categorical. We'll say post-secondary. Okay, so I'll try and be specific in a case like that. If I'm doing something like that, that might have more than one way to think about it. But you could kind of have either answer there. Next, zip codes. I did give this one away. This is a categorical. Even though it's numbers, this is categorical. Okay. Again, the math, if you try to apply math to zip codes, it doesn't give you any usable information. It's just going to be a hodgepodge of different numbers. Letter F, the daily intake of, oh, I skipped D. Let's go back to D. Household income in the previous year. Well, lots of people could have different incomes. You could find average incomes. You could do a lot of stuff with that. That is going to be numerical. Now down to F, daily intake of whole grains measured in grams per day. And again, if you're talking about a certain number of grams, that is numerical as well. Having trouble with putting that C in there. Numerical. And then again, remember the other names for categorical. You could also call that qualitative. And for numerical, you could also call that quantitative. So make sure you keep those other terms in mind. Data are the actual values of the variable. They may be single numbers or they may be words. Datum or datum is a single value. So data is when you're talking about plural, and datum is a single value from your data set. Example 1.5, determine the data of the scenario. We want to know the average or the mean amount of money that first-year college students spend at San Jacinto, I'm not sure how you say that, college, on school supplies that do not include books. We randomly survey 100 first-year students at the college. 3 of those students spent $150, $200, and $225 respectively. So the data is this list of $150, $200, and $225, and that is giving us the information of how much these 3 particular students spent on supplies that were not books. That is the end of section 1.1, and there are just 4 graded problems there. Again, you're basically classifying what types of data, what types of statistics you're talking about, and then also if you're talking about populations, samples, parameters, or statistics, we'll be classifying those different types of things.